Hello and welcome to our video project on the topic of Marangoni bursting. Have you ever wondered why water droplets exist as spheres? Have you ever seen a visually stunning display of water and alcohol? It's because of a special effect driven by surface tension between two fluids called Marangoni bursting. In this video, we'll explore this phenomenon with water, oil, and rubbing alcohol. First, watch what happens if pure water is dropped into oil. One large drop forms and nothing else happens, since water evaporates slowly. Now, we'll drop pure alcohol into the same oil. The alcohol doesn't form the same drop, and it's all gone within a few seconds. We can explain this with fluid mechanics. The Young-Laplace law refers to the change in pressure between the outside and inside of a round object. In the equation delta P equals gamma over R1 plus gamma over R2, delta P is the pressure difference, gamma is the surface tension of the fluid forming the round object, R1 is the smaller radius, and R2 is the larger radius of the object. In this case, the small droplets can be approximated as spheres. So as R1 equals R2, our Young-Laplace equation becomes delta P equals 2 gamma over R. In both cases, delta P is the same since it is related to pressure in a bowl and atmospheric pressure. The gamma between water and oil is 23 to 26 millinewtons per meter, and the gamma between rubbing alcohol and oil is 1 to 3 millinewtons per meter. To reach the same delta P, the droplets must have different radii. A pure water droplet, then, would have a much larger radius than droplets formed by alcohol, which are incredibly small and evaporate quickly. For a more interesting experiment, consider a mixture of water and alcohol, which has a surface tension coefficient between that of alcohol and water. What would happen if this mixture is dropped into oil? This effect is called Marangoni bursting. Why does that happen? The alcohol-water mixture starts to spread over the oil because of its alcohol content. But as the alcohol evaporates, it leaves droplets of pure water that do not spread. More evaporation of alcohol occurs at the edge of the main water-alcohol drop, and the difference in surface tension between the center and edge of the main drop causes the flow outwards, pushing the small water droplets outwards as well. What would happen if we change the ratio of alcohol to water in the main drop? For a drop consisting of a lot of alcohol, its spreading effect will dominate, and many tiny droplets will be formed. Back to the Young-Laplace law, notice that as gamma decreases, R also decreases. What about a drop made with a lot of water? With higher surface tension, larger droplets will form. With the Young-Laplace law, as gamma increases, R also increases. Here is the correlation between droplet diameter and alcohol content. Marangoni bursting can occur whenever a water-alcohol mixture is dropped onto a layer of oil. For an example that might come up in everyday life, we tried it with wine and olive oil. So the next time you're having an Italian dinner and notice spherical droplets spreading away in ringlets, you can explain the secret behind the phenomenon.